Hello, everyone. Thanks for coming to the 3D Design for Lasers webinar. We have Austin here, Austin Hager, and we have Shannon Hoover, who you all probably have spoken to at some point if you are Thunder Laser owners. And I am Z Kessler. You might have spoken to me on social media or, once in a while on the sales emails. Today the topic is designing in 3D. So we have a few different ways that we're going to explore doing that. But first, I'll let both of our lovely co-hosts introduce themselves. I'll let Shannon go first, although most of you probably know him.
Yeah, hi, I'm Shannon. I've maybe what you don't know is I've kind of been in the maker community for like probably 15 years now. I grew up on a farm. We built things, and then I escaped from that life. And then I worked in IT for a lot of years and just really wanted to get back into doing things with my hands. So that's kind of how I discovered the maker community. Lasering has kind of been a passion of mine for probably like 12 to 14 years. I'm not so good at like doing the same thing over and over again. Like I like to try new things all the time, which is why being in a makerspace has been great. And also why it works really well with Thunder Laser, because I have done a lot of things and I can get you like 80-90% of the way there. And then I'll kind of leave you guys to go into the deep kind of learning or the skill developing on your own as after that. So my experience has been doing lots of weird things with lasers. We can get into that a little bit more later. But yeah, that's me.
Awesome. And I met Shannon through my involvement in the maker community and maker spaces as well. So that's how we kind of came to work together. And Austin, you'll go introduce yourself here.
Hello all, my name is Austin. I'm a philosopher turned technologist. I never really got too into art when I was a kid, had very shaky hands, and then found out I could be a deft hand with CAD software on account of Snap to Grid, which led me to thinking about things and projects. I found out about, Archloft back in the day, Fuse 33 after that, and got really into laser cutting. And so it's a whole lot of AutoCAD and finding cool designs online and seeing what I can manage to get together without it being too fiddly for me, which has gotten more complex as time has gone by. So, I guess I've been doing the maker stuff for, over a decade now for sure. Good fun.
So, it's funny because I've seen Austin's work around the makerspace in Calgary, which is where our showroom is for Thunder Laser, but I didn't know who Austin was. So I'm really grateful that you're able to come here because we're often showing off your dice towers and cool stuff at events that we go to. And hey, look at the stuff you can do with the laser besides signs and stuff like that. To give context to sort of my background, I sort of came to understand the laser through going to maker spaces, and at the time they were called hack spaces. I don't think there was such a thing as a maker space at the time before Maker Faire and all those things. But I saw the first laser kind of come into the maker space and everyone started joining because they wanted access to it. And it was, I don't even know what brand it was, but it was such a big deal and everyone was kind of not sure how to use it. And it was around the time of when we first got access to like 3D printers that the average person could have in their house. So it's probably like maybe 10, 15 years ago. And some of the first projects I did were like for shadow puppetry. And then later on, I worked in assistive technology and we would make screen covers for like AAC devices for people to communicate who couldn't speak. So they would use pictures on a screen and sometimes their dexterity, it was difficult to like accurately press each button. So you needed like a little screen cover on it to prevent like accidentally going to the wrong button. So that's sort of my reintroduction to lasers. And so, yeah, it's always been kind of in my periphery of my world, but now it's like my everyday. So first we're going to have Shannon show some examples of projects that he's worked on, but also around the makerspace for some of the other artists that he's sort of met or maybe introduced to some of these skills. Sometimes they're developing them on their own, but just so you can get a context of some of the stuff that you can do and in 3 dimensions, which is not what you see every day on the forums. Like a lot of people are doing kind of more commercial things. But there's lots of possibility for commercial stuff with the 3D as well. It's just not as commonly seen. So let me know when you're ready to share there, Shannon.
Yeah, I'm ready.
Okay, yeah, go ahead.
Share screen. Okay. All right. So yeah, so I've got like a few just kind of albums here that of some kind of smaller 3D projects, or some various 3D projects that we've done here. This was just a little one that I did. A couple little sculpture designs that I did. I'm good at making boxes and making structures. I've discovered. Anyway, these were 2 kind of sculptures that I also like LEDs. So whenever I can combine my superpowers of LEDs and lasers together, I do. So this was just like a quick, maybe like 30-minute project that I kind of threw together. This one was a little bit longer here. So this one, we cut a bunch of acrylic rods and then made a base for it. And then stack them and light them up. This one actually became like a 5-foot tall sculpture that we brought to a festival. And actually, it was more than that. It was probably 8 feet tall. So that we animated and you did it at a larger scale. So I used like 3/4 inch acrylic rods that we laser engraved the sides of rods, but everything was laser cut. So, I generally design in Illustrator, which is the wrong program to design in. It should be using I should be using CAD software to do this. And it bit me in the butt a little bit because at some point I accidentally slid over like one of the structures, and then everything I designed after that was like off by like something like 0.5 millimeter, and just made the whole thing really hard to assemble and build. This was another event that we did or another festival kind of project that we did. I didn't laser cut the building itself, just because we have a CNC and it was a little bit bigger or a little bit faster to do it on the CNC. Also, our Thunder lasers like to do these vertical rods, which are about 8 feet tall, or vertical supports wouldn't have worked really well on the laser. It just, you could do it by using the pass-through, but it just was easier with the CNC. I do, however, build all my stuff on the laser and prototype it and then scale it up. And then these chairs also, you can see here's an example where I took a chair and prototyped it and then built it on a large scale. And so you can see here's my niece sitting in here. And then just because I like LEDs, I had to put LEDs in it. So but yeah, so that was, and it was kind of funny afterwards, after we made this, one of the guys who makes furniture in the maker space looked at the chairs and said, like, are you selling these? And I'm like, no, I don't have time for that. It's like, if you tidied this up and like, kind of cleaned up, like you didn't use like big heavy ready rod or whatever, it made it look pretty, because you could sell these for like $3,000 to $5,000. And so that's kind of cool, like knowing that this idea that you can take it from idea to large scale and it'll, and it actually turns into a business. One of the things I like about lasers just in general is that you can, by the way, these infinity mirror ceiling tiles were also made on the laser. And again, combining my loves of LEDs and now this was during the day, so we're seeing a lot of reflection, but at night it kind of looks like you're staring off into infinity, which was, I'm sure fun for people that were high, at the festival. But it is cool to me that there's so many different types of projects that you can do on the laser. So do you want me to go through how to make this chair, for example, or should we do that after?
Maybe let's go just do an overview of a few different projects of
So here's another project that we did. These were giant sized groceries. And all of these were laser cut. You can see the laser cut edges here. This obviously we did during the pandemic, hence all the masking in a wood shop is generally good practice anyway. But yeah, so we had the contract to build 5 or 4 of these kind of grocery things. You can see me using the software here that we'll show a little bit later, and nesting them and then cutting these on these big sheets on the laser, and then pulling them apart and then gluing them back together. So yeah, you can see this is an avocado that's slowly being built here. This is kind of what it looks like fully assembled. Here's us lifting this thing. Turns out it's about like, I don't know, 350 pounds probably. So the guy on the other side is doing most of the lifting there. He's very lumberjack-esque. And then yeah, so then that was one of them. This milk carton was another. You can see this apple here. This is it installed. This is somewhere up here is it being assembled. So again, it's very easy to take a 3D model of something, extrapolate a design, put it together, and then laser cut it and then assemble it. And these were projects that we took bids on. Incidentally, this avocado is still on the street, and we touch up a little bit of paint every now and again. We built it with the idea that it would maybe last for 6 months, 3 to 6 months. It's been out there for like 4 years, and looking amazing still. So yeah. Yeah, so that's all the kind of the large scale examples that I had. Yeah, so
want to maybe show some of Ken's stuff as well.
Oh yeah, right.
There's an artist that you probably saw in the ad or the email. He does he works at the makerspace as well, Ken Hager.
Yeah, so Ken, and we took the same idea, right? It was just a 3D model that we took and then ran it through the slicing software, and then glued it together using a bonding agent for acrylic. And then we lit it up again, combining lasers and LEDs. We lit it up from below. And these not only were a huge success for the event that we did them at, this project has turned Ken's career from working in oil field logistics to making art full time. So he still has these 6 forest guides, he calls them, and he rents them out for events. So he'll rent them out for, I don't know, $300 a night per sculpture. And he keeps on doing that. And now he's adding to his library of projects. So you can see he's got these ones, and he's also built some other projects here. This I can't really see it. The one in the background there was laser cut as well. Oh, hang on. Let me show you the hang on, promotion. Sorry, you're going to see a lot of dresses and stuff, but this is a laser cut infinity mirror project of half hexagons. This was another one of his first projects that he did. And look at when you zoom into it, you can just see it looks like you're staring into the beginnings of a universe or something like that. And I just love that, you can take these weird ideas and with the right tools, all of a sudden now you can scale this into infinity. Sometimes people will ask me are there too many lasers out there? And I'm like, yeah, sure. There's a lot of people are buying lasers, but there are so many things you can do with them. nobody's, I don't like ever done this before. And having a laser allowed Ken not only to do these cool projects, but to launch himself as an artist, like launch a new career to the extent that he gets paid. He earns a living, more than he earned when he was working full time doing oil field logistics. So yeah, it's pretty cool.
Yeah, and I have to say, one of the things that I've done in my, before laser life was do public events and festivals and things. And I can tell you that there's not enough people that are able to offer these kinds of things. Like, especially if you create it once and then you can just rent them out over and over, people will easily hire you because it's so much easier to hire than hiring someone to make a custom project every year. They can just sell, you already have it, bring it to the festival. So it's and then any kind of public event, farmers market, all these different activation things they do around the city, there's budgets for this kind of stuff. And even when the budget's low, they have it for like these kinds of things, right?
Yeah, and since we've discovered since the pandemic that these types of because we had to switch to open kind of sharing spaces during the pandemic, but since then we've discovered how useful that is as do you want to activate a community or an area, just have a festival, put some art in it, people love it. So yeah,
it really creates a vibe.
So I can go into the making of kind of the steps that it would take to do this, but let's hear from Austin here before I take up all the time.
Sure. Yeah. Let's go to Austin and then we'll jump back over to you. So just to give an overview of the sort of difference. So Shannon's kind of talking a little bit more about using the 3D software and slicing as if you're sending it to a 3D printer, but you're not actually doing that. So we'll show you how to do that later. But then Austin has kind of a different style of doing 3-dimensional stuff. So Austin, go ahead.
All right. Well, number one, you'll find that the same way that Shannon's obsessed with lights, I'm obsessed with moving parts. And number two, I have trouble keeping a whole 3D design in my head at any given time. I draft everything in 2D. The third dimension comes from the thickness of the material and gluing them together at intersections. That's the only way I can wrap my head around it. So that's how I do it. So let's see, a few of the things I've been working on recently. I actually got a couple of things right behind me here. This is the guy I put together for this class in particular. I've got an instruction set that anyone should be able to follow. It's just a 7-leaf iris where all the pieces slide against each other. You can actually see on the back how the pieces are each just moving linearly in a track, but the 7 of them together look a lot cooler than just sliding back and forth, I think.
Okay, so I got to ask a question. Why 7 and not a normal number, like a human?
So why 7 and not normal number? That's because I like prime numbers sometimes to my detriment, perhaps. If you have a nice even number of numbers, you've got every one of those lines crosses the center line. When there are 7, they sort of come to a point and it can get a little tricky. I've got an older one here where I didn't get my alignment quite right. You can see it's very stiff right at the middle. So that's me giving myself more work. Because I can, yes. It's one of those things you feel like, okay, I don't get this until I get it in a prime number. Because if you're cheating around symmetry, that's a cheat. You'll see I throw myself under the bus with this a few times. I've got this nice display here, which is a coin display. And as it moves, each of those keeps itself oriented, but not by gravity. They're actually held in place by a planetary gear system. So if the middle gear turns, all of them turn. But that's 13 gears on the outside, 7 gears for the little ones. And so you can see the outside gears are upside down relative to each other because I accidentally installed my inner gear upside down relative to each other on either side. Symmetry not being there. That's a 1-to-1 gear ratio in order for these to rotate counter once to every rotation of this. So it makes for sloppy work if you're not paying attention.
Well, it certainly does challenge your knowledge of the system, right? Like if you don't know what you're doing, then making it like this you will have to learn.
Exactly. That's exactly it. I want to make sure I know what I might be getting wrong, so I throw in those extra little challenges on things.
Just for the people watching, however, I will say using 6 or 8 or 12,
so
like
much easier.
those numbers are good numbers for doing design work because
Yeah.
things tend to make sense at scale.
Especially
Like
if you're doing gears.
What's your angle on the iris for 7? Like that's got to be like
That's easy. I take my CAD software, I tell it to make a 7-sided shape, and then I just snap to that when I'm doing my rotation.
Nice. Yeah.
Because it's just going to be a repeating decimal anyway. So I just let the CAD software decide how far down the repeating decimal it wants to go, and I don't have to think about it.
Yeah, I mean, the blessing and the curse of lasers is they're really, really precise, right? So
yes,
knowing how accurate to go is like half the trick, because if you go too precise, it'll bind. If you go not precise enough, it'll be loose and floppy, right? So, yeah.
The difference between these two is 0.1 millimeters on the lines on the outside of these. Well, yeah, that and MDF can do things a little differently than wood.
Yeah, totally makes sense to me. Sometimes when I'm building like boxes that are assembled, I'll like part of my flex is like I want to be able to make this box and not have to use glue, right? So I'll build it so the wood will just bind together, and using different types of wood means you have to change that value a little bit because MDF will act differently. It'll have different, like it'll compress differently than Baltic birch, for example.
Definitely. So let me take over the screen here for a sec. I can show you guys a little bit behind the scenes on how these get put together. Okay, share screen. And we've got the entire screen. There we go. All right, so that should be up. Okay, so here's a little peek at what's happening in one of those iris mechanisms. It's much easier for. You can see they're just each on their little linear track, and as you push any one of them, it slides the others along with it because they've all got that little double up of the structure. If you look, this is how I like to design everything. And I've actually got an underlayer and an overlayer with just a slight overhang that you can see on here as they push against, and that's what they ride on. And then when we've got that, just a sec, got that coin wheel, here we go. So this guy actually has fewer parts when it comes down to it than a lot of things I do. They're just repeated a lot. So we've got 6 of our outer gears, 1 inner gear. We got 6 of the smaller gears. We got 3 platforms. As you can see, this is one of 2 sheets for it because it's only got the one half of the stand, the one half of the base, one half of the big wheel, because it takes enough that it has to go on 2 of my different sheets that I cut. So I like to split it out that way. And it came from a fairly simple, of course, scaling's a little off. Came from a very simple baseline, just doing that up, just 3 of them, just on dowels. I decided to skip dowels so I could have more precise control over where it's going, although dowels are nice because you can line everything up and then apply glue, as opposed to what I'm doing with the current one, which is, let's see, do we have a close enough view on here? Yeah, you can see there's a little X there. I just build little pins out of a pair of pieces like those that lock into each other to make the X shape. I also really like to minimize my hardware in my designs. This would be the exception recently. This guy is a little joystick-driven table. A friend of mine wanted a display for something, which that project hasn't gone anywhere, but at least I got this design in my back pocket now.
Hey, somebody's asking which CAD software you use, Austin.
Oh, yeah. I use QCAD. I use QCAD because it's similar enough to AutoCAD that what I learned in SATE carries over, and it's relatively inexpensive. Last time I re-upped with them, $30 gets you a year of unlimited downloads and all the updates for that time. So yeah, then if it's working happily, great. You don't have to pick up another one till the next time you pick up a laptop. And this is actually the instruction sheet I put together for that 7-leaf iris. So you can see how I laid it out in design, where I've got the pieces and there's slight overlap against each other. And I can say turn off different pieces and layers. So I've got my leaf piece, and just a sec here, we can find the leaf bottom. So if I want to take out that underlayer, I can turn that off. to make it look a little bit cleaner. Or you're not gonna. Well, might have my layering a little off. Right? Oh no, because it was leaf under 7. That's right. It's what I get for borrowing from other designs while I'm putting things together. Now, I know that can kind of look like garbled nonsense if you're not used to looking at it, but it is just all of the pieces layered on top of one another. And then I have to do my side views manually, so I know the thickness of my material, layer them on top of each other, make sure I'm giving myself enough space. But when it comes to the cutting, just all the pieces laid out. And this is the document that's going to be available to everyone here. So it runs you through how to cut a couple pieces to make sure you got your sizing right, and then how to assemble the whole thing a layer at a time.
So are you making the designs for this available for people to use?
Yep. Yeah, I already gave out the link earlier,
nice.
or rather passed that along to Z. So
yeah, anyone that
not
is
in the chat,
in this,
we can.
Anyone that's in the workshop will get an email after this is done, and the link will be in there, as well as the link to the next webinar. And yeah, you can download it from Austin's site.
Yep, I just have that up there for free for anyone who wants to give it a try. And you can, I mean, I've got a lot of my other things. I usually don't go through and put meticulous instructions along with them. So you'll see in all of my designs, I've just got random little extra whatever I was thinking about as basically visual jot notes to myself. It's kind of a chaotic process sometimes. Yeah. Let's see if I'm not running up against the time you want to take over, Shannon. We've still got a couple other fun things because I did think this wave machine.
Yeah, we have lots of time. Go ahead.
Okay. Oh yeah, yeah. We're only 10:30. The wave machine is great. This thing. Actually, let me hop back on the camera because this one's fun to look at the pieces of. So I need to redo this because fun of just doing this little thin stuff. It's not enough to guide a piece. So if I don't have this little guiding grate on the top, they bump into each other. But all these are just little offset circular cams all in a row. And since each one's slightly offset, each of these is just on a little follower plate. And it just lifts them up one by one. And if you happen to have an object like a dice or a little something, hey.
Oh, that's awesome.
It'll just walk right along.
Can you show that again? Because I talked and it went to me.
Sure thing.
I'm gonna stop now.
So we got the dice, and it just comes along, kicks it off the end, because it's just much like actual waves. Nothing has to move, but because you've got the propagation of the angle can carry anything that'll be rolled along by it. I do have some plans for some larger dice machines with this mechanism, but one of these days. And then as an extra moving part, it's just nicer if the knob spins. And this is all MDF. There's no hardware in here other than that. Usually when it comes to something like this, I just cut the hole out of the handle so that little bit of hole gets the little X pin driven through it, and the space cut by the laser is more than enough to let it spin very freely. Sometimes when you have things adjacent to each other, you have to worry about the kerf. But the kerf, when you're cutting a bearing, oh, it's perfect.
Nice. So I just gonna say I need to steal that design, and we need to make one out of it's double the size out of 1/4 inch for the event in June. So.
Oh yeah, hit me up. This is very easy to scale because all you need are plates with weights and an offset cam. Like the bigger it is, honestly, it gets easier and easier because you can just run a long dowel through it and you can actually screw through your cams, because you try to screw these things, they're going to get torn apart. But got something 1/4 inch or larger, ooh, that's handy.
Well, often the way that I build my prototypes and then I go to production is I'll just do my production design and say I'm intending to do it out of 1/2 inch or 3/4, and then I'll just scale down my prototype to be the exact same design but out of an 1/8. So then my chair, that was the chair is the exact same design, this size as it was, on the larger one, just out of 1/2 inch instead of 1/8 inch, right? So then I don't have to make any changes.
Then the sloping on the cut line doesn't end up throwing you off? I guess the amount of slope there is on it is actually quite small when you're talking about something that's a half inch instead of something that's an eighth.
Yeah, no, I generally don't see that. There is like I do find that sometimes my tolerances will change just because at a half inch things bind a little bit more than they would at like when you got something at a larger scale, right? But very generally very little has to change.
Okay. All right, and I guess last thing here. This is the fanciest dice box I ever made. This was for a charity. This is one of the many prototypes I made for a charity event called Desert Bus, which is why there's a bus that drives along the top. This is just one gear on the side, one gear on the back, and down the middle is a spiral staircase of steps. And so that spiral staircase will drive anything that's along the top, thanks to a little angled plate, but also anything like a dice that gets popped in here and just walk up and walk up and walk up as it gets pushed, and out it goes. Basically an Archimedes screw, but instead of for water, it's for dice, or a grain auger if you prefer something a little more modern as your reference.
That's pretty cool. I show that one all the time.
All right, are you ready to tackle software, or you want me to pull out a couple more gadgets over here?
Z, how are we doing for pacing? I can jump in to do
we can have a few more minutes of Austin stuff for sure.
Sure, yeah, I got a couple more things I haven't looked at. Here we go. So this one is just an attempt at chaotic motion in a fixed gear system, thanks to things being, what was it? Yeah, 15, 7, and 15, 7, and 13 gears, so none of them share a prime factorization. So as this turns around, now the points are a little bit long, but it becomes very hard to tell exactly where it's going to go as it goes through, and it takes a long time for all the hearts to line up again. And mostly just to see how off I could make it look. Since it's just bobbing back and forth, it doesn't actually have quite as much effect as I wanted. It's also got a little gremlin holding on the crank on the other side, though. It's lost one of its pins already, unfortunately. It's got its little tongue stuck out, if you can see that. Held together with a bit of tape because I didn't have my spacing quite right. But in there is just gears on gears on gears. It's honestly just the 3 gears. I just belt and suspenders repeated them every time anything met a surface, which was a little bit of overkill. I could have gotten away with just the 2 pairs in the middle, where it goes from being an axle straight through to being the offset axles that are driving the little flying guy on top. Right.
Like you're recreating the 3-body problem.
Something like that. It's not quite as likely to fling off into infinity, fortunately. We got much simpler mechanism.
That was a very nerdy joke, by the way.
Yeah. This guy was just to create a table that tips over time. It was actually one of the possible designs that led to the joystick one I showed you earlier. This guy is the gear drives an offset, which slides that one back and forth. And because it's offset on the gear, it's dragging the table up and down with it. And then the mechanism I haven't quite nailed just because of the properties of glue. I think I have one of these over here. The simple one, I'm sure you've all seen them before. It's a timbre box. So drawer opens, pulls the top with it. But at 1/8 of an inch, you'll find when you do the traditional method for making timbre, which is throwing some fabric and a whole bunch of glue on it, 1/8 inch wood warps like crazy when you saturate it with glue. It just goes angles everywhere. So this one's put together with gaffer tape, which doesn't like to hold on as well as I'd like, especially once the tongue oil that I finished this with got into the adhesive. That was it. No go. That's why you can see the end piece really wants to come off of this guy. So one of these days, I'm going to take another run at it and figure out what exactly I want to do to try to seal that in properly, or just if there's a way to mechanically lock both the beginning and the end. Because all that's happening here is you've got this line of slats. They're attached to the tape and they're attached to the drawer. So as the drawer moves back and forth, they're just pulled along in the track. And because they're butted up against each other, they can't twist out. And of course, it's decorated because if you're doing something on a laser and you don't take the time to decorate it, why were you even there? Come on, you got to have fun with it. That knowing top and bottom is handy. Plus,
you got to cut and engrave.
Pieces. Exactly. I swear, sometimes I do actually end up spending almost as much time on the engraving as I do on the cutting when it comes to my cut time. But, you got to find the things that make you happy. Oh, yeah. Can I get this on camera? Maybe. Let's see. I might knock everything down.
I'm really curious.
I want to see everything get knocked down.
Okay.
That's what we all came for.
Here it is.
Oh, this thing. Yeah, it's so cool.
So we've got a little animated critter. It's got a tail that waves back and forth. That's just pulling some fishing line on either side of some zap strap. And then we've got the breathing mechanism, which is a scissor lift that's driving a series of geared ribs. So as it breathes out, the ribs close in and the chest drops. And there's also a little heartbeat light attached to everything. Obviously, I haven't rebuilt my control enclosure. This is one of those things that's been sitting in storage for years that I finally dug out for this. So one of these days, I might just get around to finishing it. But yeah, it's come to a couple Comic Cons with me. And again, you got to put some decorations on it. If it's going to be a weird eldritch creature, they need to look vaguely mystical. So back to prime numbers, we got our 7 points on there.
I like how you use the zip ties. Are you still using zip ties for that as springs to keep it open?
Exactly. Yep.
That's really clever. I like that.
They get to be ribs and do mechanical work for me. Although if you make them too small, they fight that motor so much that it just can't keep up. So there's actually a minimum size it can get down to, because otherwise the spring potential of the zap straps beats any motor that I can throw on it.
So a lot of schools that are interested in laser cutters, they could apply this type of stuff that Austin's doing to making robotics chassis for their robots, and we've seen a few schools doing that. And speaking about, that's part of their intention of having the laser cutter, which is really neat. But yeah, so we got 9:38 my time anyway. So maybe we'll switch over to Shannon if you want to give a little demo of the slicer program. So yeah, maybe you should explain, because you've been using this program for a little longer.
Yeah. Okay. So basically, hang on, where's my screen here? Share. Basically, it does the same thing that a 3D printer slicer does. It just does it. It just does it for laser cutting. Now, the software that I use is software that isn't supported anymore. So if I go to, if I type in the name of the software is Slicer for Fusion 360. Okay. You don't need Fusion 360 to use it, and it's free. So if you go here, the top, you just search for Slicer for Fusion 360. We can probably include this link too for people. Hey,
it's in the follow-up email. Yeah.
Perfect. Yeah. So you can see that Autodesk support, it's no longer maintained, blah, blah, blah. It's no longer maintained and supported, but they do have a version for Windows and Mac. I would suggest grabbing it. And I thought I had it open, but I don't. So I'm going to just open it here in my computer. This is the software here. I can just go and open, I'm just going to open an example shape here. I'm going to go with this relaxing chair here. And you may actually recognize this from one of the photos that I did. I actually built this chair just as a test. Anyway, so here's the design. In the software, you can go and edit your material. This is all very small, so I apologize, but you can see that I've set up a new manufacturing material here that's a 4 foot, 90 by 8 foot, so 48 inches by 96 inches. And then the thickness is a 1/4 inch. And so you can see that I've developed a piece of material here. So if I select that piece of material, I can now go in. Let's say I want to make this, say, 24 inches high. I just change this to 24. It'll scale that up. And then I'll go select a technique, stack slices. And for some reason, it's generated 0. Okay, it's because I need to reselect this. Okay, there we go. So now you can see that here's all the different levels, and here's the files it's generated. So this is like, I just want to reinforce how stupidly easy this is, considering how much math was just done in a matter of seconds. The one thing that annoys me a little bit about this is the software is terrible at stacking. So I obsessively take all the designs and restack them to save on wood, because wood is very expensive these days. But yeah, like it's generated 5 different cut files for me. It numbers them for me. And if you zoom in, you can see there's little holes here. It actually marks and cuts little holes, so you can put pins through and align it to the layer below. And then these lines here, these show kind of the edge of where the next piece is going. So this 6 here, if I were to drag it over top, it would show, the 8 here. If I put the 8 on the 7, this edge here would line up with this red mark here. So it makes it very, very easy to build. But the other thing is I can also go in here and I can say I want to add dowels, okay? And it's going to automatically dump dowels in here for me, but it's put way too many of them. I really don't need everything to be doweled, but I can drag these dowel spots around, and put them in kind of where I want, or I can just click on them and delete them if we have too many of them. But I might want to put like 4 dowels in here, right? So I might want to put 1 in each of the corners. And then that way you notice that if I go into here, that the dowel holes are now as part of the design. It is like almost criminally easy to do very complicated things here, to the extent that, not to sell out my good friend Ken, because he's a smart guy, and and I celebrate the fact that he has built a career in art, but he did it on the backs of this software. Now his stuff has gotten very complicated, and like the rest of us, we get obsessive about things and we go down rabbit holes, and Ken's very much like that guy. But to start with, he was able to develop these 6 designs and use this software to make it for him. And those are still like some of his most popular art that he still rents out to this day for like does really, really well by it. So this software is amazingly robust and simple to use. Now, that's the chair. By the way, the next step would be get plans, and then I would download these as a DXF, or you can do it as a PDF, or DXF works fine. And then I would just take them to laser and laser cut them after restacking them, because this is terribly inefficient at stacking. But yeah, so let me go. Let's say that I want to do something a little bit different. So I'm going to do a human head here. No, I don't want to save it. And again, this is like not coincidentally, I turned this into an art project as well. And I'm going to be honest with you here. I made an art project out of a example shape in this software. So I put like almost like less than 0 effort into the design side of things. And to be fair, I just did this as an example, and then the art kind of lead for one of these festivals walked in and saw my sample and says, I want 6 of these. And I'm like, all right, fine. So anyway, so I've got a human head here. And then we're going to change it, our size. We're going to make that like say 36 inches here. And I'm going to choose my technique so I can do stacked slices. Now you can see there's a lot of slices here, but let me switch to this material. So you can see now there's a lot of slices that's generating. So I'm going to, instead of stacked slices, that's too much, right? So I can go interlocking slices, and boom, the same size of file. And now all of a sudden I'm doing it on 2 sheets. I could maybe even squeeze it on 1 if I was careful enough. Now, so this is my shape here, and you might recognize that the apple was done this way. But I didn't use stacked slices. I used radial slices, and this goes out from the center, and it just looks a little bit nicer, I think. I can add, like on like my vertical axis, I can add layers here, or on my horizontal axis or my radial axis, I can add layers here as well. So you can see this one, there's one going right down the nose now when I get to 12. I can also go in here if I want to, and I could like drag this one specifically up or down. And you can see on the right-hand side, look at how the design is changing automatically as I drag this up and down. Like I don't know, I just find this so fascinating and so cool. I think I can drag these around as well. And yeah, look at the design, how it's like changing in real time. Anyway, enough playing with that. I can also go in, like change my slice direction here. And I can click on this. This is a little bit tricky, but I click this and drag this here. Oop, there. And now look what it's done. Okay, I can go and modify my form. So you know what? I don't like the fact, this is a little disturbing. I don't like the fact that this is on an angle like this. I'm just going, that this is using so much material. I'm just going to click hollow, and then it gives me this kind of design here. I'm going to drag the slider, and you can see in the center there's a hole appearing. I can slide that to the right, hit apply, and watch. Again, my design on the right changes. It recalculates all this. And I don't even want to think about the amount of math that's going on to make this happen. Like this is insane, but I'm able to do it just in the matter of a few clicks and a few seconds. So I just love this software. I use it for all sorts of stuff. There's a lot more you can do with it. Let me just show you a quick example. So this is Tinkercad. This is my CAD level. This software is made for like children, and it works so that it works well for me because it's made for children. But I'm just going to take a couple shapes here and I grab this shape. I'm going to drag it up. Okay, I'm going to drag it on top of. Drag it up a little bit more. You can drag it on top. In fact, I'm just going to select both of these, and then I'm going to align to center to center. Remember, this software is meant to be used by 8-year-olds, right? Okay, so I'm going to take this shape here. I'm going to weld it, so it's now all one shape. I'm going to take it, and I'm going to copy and paste it. I'm going to scale it down just a little bit here. I'm not thinking about this too much. I'm just being very, very quick with this. And then I'm going to make this one a hole. And then I'm going to combine the two of these. Again, I'll center it to center and center here. And then if you flip it over, you'll see there's a hole on this. And I will now weld these together. And now you can see my shape has a hole in it. Okay. I'm going to take this. And for whatever reason, the software, like the Autodesk software, hang on, let me flip to the side here. I'm going to rotate this to 90 degrees because it, 90, there. Because the Autodesk software likes it to be on its side. I'm going to now take this here and I'm going to export it as an STL. We're doing this live here, so there's the chance that this is going to mess up and make me look stupid is probably fairly high. But anyway, I'm going to go to import. Do not want to save it. I'm going to, in theory, open. Oh, okay. I have, let's go with wait here. Okay, let's close it. I'm not sure what happened there, but you know, it's not a big surprise that software that isn't supported crashes every once in a while. All right, so open from my computer. Downloads. Downloads. Why isn't it? Downloads. It should be here this year. Where did that save to? Saved to downloads here.
Yeah, looking in your open, it wasn't looking for STL files.
Yeah, why? You're right.
Got your
there
file drop
Oh, I
down.
see. I shouldn't be opening. I should be importing. New import. There we go. I got to click on the very obvious import button. Oh, now it's
except for
all right.
not responding.
Okay, so it's still spinning here. Import. There we go. From downloads. And let's grab. Okay, so I don't remember what it named it as. I think it was this smashing fluffy. There's my design file. I can give it my height. Let's say I wanted to make this 24 inches, or let's say whatever, 24 inches, fine. Stack slices. Let's choose a bigger sheet than an 8.5 by 11. All right, and there we go. There's my design. So now I'll just have to laser cut it and glue it together, and we're done. You know what? Let's do it as a radial slice, just because I like how that looks. And there's my file right there. If I wanted to make a vase, and I could coat it on the outside, like cover it up or whatever, but that's my shape. So the fact that I was able to do this whole thing in like 6 minutes is nothing short of like amazing, I think. And I would encourage, even if you're not going to do this, like this software is a lot of fun. Even if you're not going to do this like for work or for a paid job or something, it's a lot of fun, and it drastically expands your capability. So, all right, that was my very risky, oh look, it's trying to open something in the background. I must have double clicked on it. Okay, the other thing that I'd like to just quickly jump into here, very, very quickly, is this Boxes PY program. And this will give you some of the skills of Austin without getting into his brain. This is like open, it's free software on the internet. I just type in Boxes space PY, and it gets me there, the top link, but it's the link is festi.info/boxes.py. And if I wanted to make, let's choose something fairly complicated, like this pirate's chest, for example. Here's the design what it's going to create, but I can go in here and I can say I want something that's like 250 millimeters wide. The number of sides in the lid, let's say 12. The thickness of material. You know what? I'm going to do this as light burn because, I have light burn. I can go in and I can change my settings for my hinges or finger joints or whatever. I don't need this reference value in there. My inner corners, because it's a laser, should be a corner, not a loop. Loop is used for CNCs. And my burn, I'm going to go 0.05 millimeters. I'll hit download. And in theory, it should download as Lightburn file. Still thinking here. And then I can just drag this file into Lightburn and have my Pirate's Chest box. This software is like there are probably like, I don't know, there's probably like, this doesn't really show it. Let me go to menu here. In the meantime, I'm going to open Lightburn and grab that file. No, don't download. A pirate chest. There it is. Drag the file in the Lightburn. And here's the Lightburn file for that pirate's chest. So isn't that amazing? Just in like no time at all, you're able to create something that's like very, very useful. If you go here now, you can see boxes with flex that has all of these boxes. Shelves, hole patterns. This box here, look at all the different boxes. There's like 25 different like recipes for boxes. Miscellaneous has some fun things in. There's a birdhouse. Makita power supply. Who knew? Yeah, triangle lamp. Feel like I need to make one of those now because it has an LED in it. Anyway, unstable. It's got designs for a castle. I mean, who doesn't need designs for a castle? Here's some planetary gears. Anyway, silverware. I don't even know. But there's so much you can do with this software, and it's free. Pizza shovel. Oh my God. I need a pizza shovel. Anyway, I'll explore these later. There's new things. I swear these weren't here when I checked last because I would have noticed the pizza shovel. Yeah, so that's the box that PY. There's lots of other software that allows you to do cool stuff as well. But anyway, that's let's look at the pizza shovel. Oh my God. It's a pizza with a conveyor belt. Okay, later. I'll look at this later.
Okay, so we only have a few minutes left. So if anyone has any questions, put them in the chat. And if we aren't able to get to them right now, we'll put them in the Thunder Laser Canada Facebook group, not the page, the group. And also all these websites that Shannon's mentioning right now, I put them all in the follow-up email. There's quite a few different box programs. There's also ones for puzzles, gears, mazes, all sorts of crazy things. So yeah, if you haven't already come across these, I'll send you a link for that. Tinkercad, Fusion 360, and Austin's file there. Oh, they're saying the laser.
I just want to shout out to Gary. I've done a terrible job. We need to share more of your stuff, but also share all because you guys, there's such cool projects coming out of Protospace and all maker spaces. Well, I mean, everybody. If you design something you think is cool, like tag us in it and we'll share it. We'll share it out. But yeah, I love kind of the creativity that people are coming up with these machines. And you know what? Like, spoiler, I realize we all have to earn money and make a living. But that's not what I care about. I care about like designing cool things. So yeah, that's we're all at heart, we're all makers here, and that's what we love. So.
Totally. Yeah. So someone Stefan was asking about where to get the STL files. So Thingiverse is a good place. You could just type in open source 3D files and there'll be a few different sites, but Thingiverse is probably one of the most popular. When I worked in assistive technology, we found a lot of files on there and we'd refine them or whatever needed to happen. So if you haven't tried out Thingiverse, that's a great place to go to get your 3D files that are already created for you. You don't have to create them yourself. It's a good way to practice.
Yeah, and the other thing is, like, don't be afraid to ask. Like in the Thunder Laser Canada group, like on Facebook, we will post response with our best knowledge, and the community is often your best resource for this sort of stuff because everybody has their own rabbit holes that they go down and are experts in, right? So yeah, the more we can share, the better.
Yeah, excellent. So for next webinar, I'll be hosting it about marketing for your laser business. So in the follow-up email, you'll get an invite for that. So if you have any specific questions about like how to get found on search or ads or anything like that to do with the marketing side, or what website's the best to have an e-commerce site. I know some people are sort of in the beginning stages or maybe even really successful just doing it on Marketplace, which totally works. But if you want to level up and start doing an e-commerce site or any sort of having a system to keep track of all your orders, I can help with that sort of stuff. So that's the topic of our next webinar, which I believe is June 6th. So I hope to see you there. And thanks everyone for coming. This has been really fun. And yeah, we're pretty much exactly on time. So drop any of your questions into the Facebook group for Thunder Laser Canada, and we will answer them and post the this recording on YouTube as well for Thunder Laser Canada. So if you want to watch it again, you can go over there for details, or just to go over some of the instructions that maybe you need to look at twice. And yeah, thanks everyone. Happy
All right,
making,
thanks,
happy
guys.
lasering. Bye.